Hello friends, welcome to Tech Study Cell. In this video we will discuss how to store data permanently in the ESP32 flash memory. I have received lot of requests to make the ESP32 project with EEPROM library, but now it is not possible to use EEPROM library with ESP32. Instead of that, we can use preference library to store the data permanently in the ESP32 flash memory. First, let me give you a quick demo. This is the ESP32 and this relay module is connected with the ESP32 and these 8 lamps are connected with the relays, and this blue LED indicates it is connected with the Wi-Fi, and I have also used IR receiver to control these lamps with the IR remote. Now let me turn on the first, second and fifth lamp. Only the first, second, fifth lamps are on. Now if I turn off the complete supply of the ESP32, you can see currently ESP32 do not have any power supply and all the lamps are off. Now let me turn on the supply again, and you can see the first, second, fifth lamp turns on automatically after we restart the ESP32. And for this project I have used the ESP RainMaker, so you can control all these appliances with Google Assistant, Alexa, IR remote and manual switches. And if there is no internet, still you can control appliances with manual switches and IR remote. Here you can see I have made the complete circuit on 0 PCB, but I will always recommend you to use a PCB to avoid any loose connection, and you can easily design professional PCBs for any electronics project with the Altium PCB designing software. Altium is the most trusted PCB designer software by all the big electronic companies. With Altium, you can easily search any electronics components, compare the datasheet, and it has lot of useful features which will save you a lot of time while routing any complex PCBs. There are a lot of tutorials available on Altium, and the user interface is so simple. You can easily learn this software and use it to design PCBs for your upcoming project. I will highly recommend you to download the free trial version of the Altium PCB designer software from the video description. During the video, I have explained all the steps to use the preference library and what are the limitations. So after watching the complete video, you can use the preference library for any ESP32 project. So without any further delay, let's get started. First, let me explain what is the preference library and how to use it. As I said, preference library replaces the EEPROM library and it stores the variable value in key value pairs. And to store the data, it uses the portion of the non-volatile memory or NVS of the ESP32. And you don't have to install the preference library separately. If you have already installed the ESP32 board, then it is already installed in your Arduino IDE. So if you are using preference library, then first you have to define a namespace, and under that namespace you can define multiple key value. In this example, you can see Wi-Fi credential is the namespace and SSID is the key, and this is the value of the SSID key. In a similar way, pass is the key and this is the value of this pass key. So in this way you can store multiple data using the key value pair. So if you use preference library, then you have to include this preference.h header file. Then you have to create an instance of the preference. Then with this begin function, you can define the namespace. As I said, first you have to define the namespace. So relay state is a namespace, and this false argument indicates I have opened the namespace with read write mode, and if it is true, then it will open in read only mode. And you have to remember the namespace name is limited to 15 characters. You can refer this article. I will share the link in the description. Now let me discuss an example which can remember the last GPIO state after the reset, and for this you just need a ESP32 board. We will control this built-in blue LED with this boot button. So this is the sketch. You can download this sketch from this button and open the sketch in Arduino IDE. So in the sketch you can see first I have created an instance of the preference. Then if I go to void setup, here you can see with this begin function I am defining the namespace which is GPIO state, and this false indicates I am opening the namespace with read write mode. Then with this function it is trying to fetch the value of the state key, but if you do it first time there is no such state key available in the NVS flash memory, so it will return false, otherwise it will return the value of this key. Now let me go to void loop. So in the void loop you can see whenever I press the boot button, it is changing the current state of the LED, or it will toggling the state of the LED and accordingly turn on or off the LED. After that it is storing the current state of the LED under this state key. So with this put function we are storing the LED state in the NVS flash memory. The code is very simple. I have also explained this code in this article, and again you can find the link in the description. After programming the ESP32, if I press the boot button, you can see the blue LED turns on, and if I press the button again, the LED turns off. Now let me turn on the LED. Now if I remove the supply from the ESP32 and reconnect the supply, the LED automatically turns on as it can remember the previous state of the LED. Now let me turn off the LED. Now again I will remove the power supply and reconnect the supply with the ESP32, and the LED remain turns off, so it can remember the previous state. And this is a very simple example. Now we will move to our main project where we can store the last states of all these 8 relay in the NVS flash memory. These are the required components for our next project. Now we have to connect all these components as per this circuit diagram. Here you can see these switches are connected across the GPIO pins and the ground pin. And for the IR remote control, please use a IR receiver with a metallic case. And if you want to use push button, then you can refer this circuit. And please take proper safety precaution while connecting these appliances with the relay module. As you can see, I have made the complete circuit on this 0 PCB, and you can also use this PCB for this project. I will share the Java file in the video description. Now we will program the ESP32 for this project. These are the source codes for this project. You can download all these codes from our website iotcircuithub.com. Just visit the article link given in the description. Then you can download all the codes from these buttons. After downloading all the codes, first you can use this code to get all the hex code of the IR remote buttons. I have already explained the process in my previous video. Now if you use push button, then you can refer this code. You can see button in the code name. And if you use latch switch, then you have to use this code. Let me open the code for the switch. In this case we will use the ESP RainMaker, so you have to update the preference link, then install the 2.0.3 version of the ESP32 board, and you have to install the IR remote library. And again I have mentioned the version of the IR remote library. Then here you can see this is the instance of the preference, and these are the names of the devices. If you want, you can change these names. Then you have to update the hex code of the IR remote buttons. Now let me go to the void setup. In the void setup, first we are opening a namespace relay state with read write mode. If I scroll down again, and at the end of the void setup I am calling this get relay state function. So if I go to the get relay state function, here you can see we are trying to fetch the data from the flash memory of the ESP32 with this get bool function. And if there is no such key relay 1, it will return 0. Otherwise it will return the value for this key, and we are storing that in the toggle state and accordingly turn on or off the relays as per the previous status. Then we are trying to send the real-time feedback to ESP RainMaker. And in a similar way we are doing the same process for the relay 2, relay 3, like that. Now let me go to the void loop. In the void loop we are calling this IR remote for IR remote control and manual control for controlling the relay with the manual switches. Let me go to the IR remote function. So in the IR remote, first we are checking if there is any data available from the IR receiver. So if there is any data, we are comparing the data with the predefined value and accordingly turn on or off the relay. Then we are storing the toggle state, which is the current state of that relay, in the ESP flash memory using this put bool function. So if you go through the code, you can easily understand. And if you refer the same circuit, you just need to change the hex code of the IR remote buttons, and if you want you can change the device names. After doing these changes, you can directly upload this code to ESP32. Just go to Tools, select the board as ESP32 Dev module, partition scheme will be RainMaker, and then select the proper port, then hit the upload button. After uploading the code to ESP32, press and hold the boot button for 4 seconds, then release it. Then you have to open the ESP RainMaker app and scan this QR code. I will also share this QR code in the video description. After that, enter the Wi-Fi credential and you will find all the devices will be added in the ESP RainMaker app. I have already explained all this process in my previous video. After programming the ESP32, I have given the supply to this circuit. Now let me control the appliances with the ESP RainMaker. As you are using RainMaker, so you can also connect Amazon Alexa and Google Home with the RainMaker. I have already explained the process in my previous video. Now the first 4 lamps are turned on. Now let me turn off the complete supply. So ESP32 do not have any power supply right now. Now let me turn on the supply again. And you can see the first 4 lamp automatically turns on as per the previous state. And you can also control the appliances with the manual switch and IR remote. So this is a very useful IoT project, and I hope after watching the video now you can use the preference library for any ESP32 project. So if you find this video helpful, please give a thumbs up and share it with your friends. Don't forget to subscribe for more such videos. Thank you for watching. Have a great day.